problem number 3296, minimum number of seconds to make mountain height 0. You are given an integer mountain height denoting the height of a mountain. You are also given an integer array worker times represents the work time of workers in seconds. Okay, the workers work simultaneously to reduce the height of the mountain. For worker I, to decrease the mountain's height by x, it takes workers time I plus worker times I multiplied by 2, okay, till x. Plus, for example, to reduce the height of the mountain by 1, it takes worker time I seconds. To reduce the time, okay, so by seconds. Okay, and okay, return an integer representing the minimum number of seconds required for the workers to make the height of the mountain 0. Minimum number of seconds. Okay, so is that okay? So the integer mountain height, I think it will be a positive integer. Yes. So it's at least 1, and the worker times is at least 1 as well. Okay, so yeah, maybe we can have workers mountain height as mh equals 4, and worker times is like 1. Then for this, how many seconds do we need? So to reduce, so we need to reduce the height by 4. So it would be worker 1 plus 1 multiplied by 2 plus 1 multiplied by 3 plus 1 multiplied by 4. Okay, and this will be 10. 10. Yeah, 10 seconds. And let's check the first example. So when okay, maybe use the second one. So mountain height is 10 and worker time is 3, 2, 2, 4. Okay, then we'll have so if we ask the first worker to reduce mountain height by 1, yeah, worker 0 reduce the height by 2, it will take 3 plus 6, yeah. So when we ask worker 0 to do the work, or worker 1 reduce the height by 3. Let's see, okay. Need the minimum seconds. Is there? Okay, so since this is all positive integers and we want to reduce like the height to reduce will not change due to the worker's work time. Let's say it will be better if we use for reducing the same amount of mountain height, it will be more efficient if we ask a smaller, like the worker time is smaller to do the work. Since it will only use for reducing the height by 1, then worker 0 needs 3 seconds, and worker 1 needs only 2 seconds, and worker 3 needs 4 seconds. So we should always select. I think it will be better to ask the smaller worker time to perform the work. Okay, but if we ask ask worker 1 to reduce the amount of but it will increase after it has done the work, so it will be better to ask everybody to do the work for first. After the worker 1 works one time, it only reduced 2 it reduced 1 for height, and the time goes 2 seconds, and the other will be 2 seconds as well. And then the next, I think it will be so every time we need to choose the last the last worker times to perform the work, and after performing the work, we should, since next time, we should change this worker time to the next worker time, since it will change after seconds. So 3, 2, 2, 4. Then if we first use 2 seconds, then it will become now MH is 9, and 2 seconds left is used, and then we should the next work, this will become 4, since the next time we ask him to perform the work, it will be 4. So let's do 4, and Next, we will ask this worker to perform the work. Then MH will be 8, and it will be 4 seconds. And the worker time will be 3, 4, 4, 4. And then next time we will ask NH will be 7, and it will be, we will ask this guy to perform the work, and it will be 7 seconds now, and the worker time will become 6, 4, 4, 4. Okay, so is that the thing that maximum number of seconds needed is 12 seconds? Oh, I think some misunderstanding. Oh, it works simultaneously to reduce the height of the mountain. So that means worker 0 reduce the height by 2. And use 9 seconds. 3, 3. Okay. Okay, that's 3, 2. Okay, we choose 2 first, and then the second 2, and the second and 3. Now for 7, we will have let's see, we'll have 6, 6, and it will be, we will choose this. Oh, sorry, MH will be 6. And it will be, I think it's that we shouldn't add up the seconds. Is that like, so we will choose it will be 12. No, it's the third time we ask. We'll first use this since it only requires 4. And this second, I think we shouldn't just add up like to 11 seconds. I don't think it's correct. It should be, we should calculate each of its seconds. These are all 1 second used yeah. No. Oh, this is 2-second use. This is yeah, I think it will be better to 12 seconds. Yeah, I was thinking. Maybe we need an array or like a dictionary to memorize each worker had already worked how many height does it reduce already. And we will select the one that does not reduce the height for like the minimum height among the workers that has reduced. So I think we should I want for each iteration I would like to know who has reduced the minimum, reduce the min height that workers the min height reduced among workers. Choose a worker that has select the worker that has and also when they have the same, then choose one that has that use minimum seconds. So I think we need like 2 minimum hips to record, to keep track of the reduced height, and the other hip will keep track of the seconds, and we will use a tuple to we'll have the index as the key, so that we can so that we can map to the time and the height. Okay, so first hip, 2 hips, and but I'm not, like, I don't know when they have equal heights, like when they all have equal heights. Okay, so or maybe not, like, we don't need 2 hips, but we will have we'll have the hips for seconds. Min hip for seconds, and we need to record, we need to keep track that each workers had reduced how many heights. Or we can for loop. I'll say I think, like, we will, maybe we will use a while loop, and so if the reduced height is smaller than mountain height, then we'll keep running the for loop, and inside each iteration we will choose the one that has the minimum seconds. So select select the min seconds, and also record its also record the height it reduced and change its seconds. Yeah, okay, and so this time complexity will be we'll have Hipify the first thing will be, Hipify the work times will be ON plus the height to reduce. I think it would be at most N. Yeah, and for each operation with the hip, it would be log N. Yeah. So that's first Hipify. I think I would like to keep the index inside the hip, so it will be a tuple. I want like a hip, and it will be I'll say worker time. Let's have WD, and it would be okay for I and value in enumerate worker times. So this will be value and I. Okay, and Hipify this. I want every time the minimum. Okay, so okay, and reduce height. Let's have reduced h equals 0. So while reduced h is smaller than mountain height, then we will select the minimum seconds. It will be this. WT with index. And we still have to maintain an array to check. It's reduced, every worker's reduced height, so that we can calculate its next worker time. So we'll have reduced height RH equals 0 with n. Let's have n equals length worker times So RH this height I index well plus 1, and the total reduced height should be added as well. Oh, and the total seconds. It's 0 first. Okay, so reduced height will be plus 1, and work seconds will be yeah, we cannot add it. Not sure how to. Oh, maybe we can add at the end. Okay, let's do worker seconds later. So let's reduce the height. Okay, and then we will update the worker time to the next to the next amount of time it will use in the next time. So it will be new min seconds will be min seconds use that's I think I'll have hip replace WT with min seconds. Yeah, I'm thinking whether should add like is it min seconds added yeah, I am a bit confused about this value. Okay, maybe let's press and we will return work seconds. Yeah, we have its yeah, I'm not sure to use like worker time when it is when it reduce height by 2. Should I record this or the whole 9 seconds? Like, I am not sure. Okay, maybe try run and see what it will go. So yeah, like we have 10 and 3 to do 9, 3 to do 4, sorry. And so for the first iteration, we will have 2. Yeah, we will select 2 with index 1. So we will have 2, 1 equals, yeah. And RH, it will be like 0, 1, 0, 0. And this is going to be 1. And the next step, it will be, we will select, yeah, if we add it to the next 2, then we will add but then we don't know. Yeah, if we change to 4 plus, yeah, if here we change it to 3, 4, no 4, but 6 to 4. Then we will select 2, 2, and it would be 0, 1, 1, 0, and this will be 2. Does this mean doing the work simultaneously? Okay, so now we will have 3, 6, 6, 4. Then we will choose 3. So it will be 3, 0, and this will be 1, 1, 1, 0, and then this is 3. And this will be 9, 6, 6, 4. And then we will ask 4. So it would be like 4, 3. And this will be 1, 1, 1, 1. And we will have 4 now. Reduce height, and this will be 9, 6, 6, 12. So after the first round for everybody to work, the next round will be 6. Is that correct? 6 for index 1. be 1, 2, 1, 1, and this is 5, and we'll have 9. This will be 12, 6, 12. Okay, then after this we will have 6, and this will be 12, and this will be, I don't think this is working. See the solution? Okay, so it seems like I think I didn't get the problem really well. So like for each, when you reduce only height by 1, it's like here, and if you reduce height by 2, it's here. So like the total amount of time using, you should plus each other. Yeah, so I think if the solution using a tuple thing and having every value in each node is very clever. So we can do it like but yeah, why this is like total? I think total is 0, since you haven't yeah, that's maybe total is 0, and then we will have current value. I will say the next value we will use to reduce the height, and this will be the base. So value, I'll say total time with next span, next time, next seconds to spend. But yeah, like then we need to memorize the reduced height. So when reducing one, okay, so every time, like every time we should add its work time by base, and this is base. So I think I'll have total seconds, and then its current use and the base. So the new value will be total will I'll say plus current, and this will be current plus base and base. Yeah. Okay. So next time we will choose the last worker time to do the job, since since it can use a less amount of time to reduce the height. Oh, and height will be reduced by 1. So and we will return okay, so I think we'll return the maximum between the total value we need. Okay, so it will be for let's say value in that's for total in worker times. I'll remove this, don't enumerate, and total. For total and it should be WT. Okay. Okay, let's try run this. So we will have zero base current base and zero current base, and when reduce height is this is 0. Let's write it here, down here, and we will have when reduce is 1, we will select this. Then we can select both of them, but we will select this. Then it would become 1, and this will be 2, then still 1. Okay, then next we will select this, then it would be total will be 5, then we will have the next 10, and we will have 5 base. This is 2, and then we will select this. we will select this since it has a smaller total. So this will be, since we reduce height 3, this would be 3 for now. And this will be 3. Yeah, since we're doing 3, it's yeah, and this will be 1 as well. Then the next, it would be like 4, reducing the mountain height. This will be 6, and this is 4. Yeah. Yeah, since this has the smaller, so we will do like this. And okay, so it's time to select the 5. So we will have we will have 15. And this will be 15. Oh, but why it's not? I think I'll change this to the middle tuple to the current reduced height. So this will be 0, and total will be next total. Yeah, so for every iteration, we will select the minimum total, minimum next total, and choose him to go for work. Okay, so for this, it will be value. Yeah. So this will be height, total, so for this will be base, multiplied by height plus 2. Yeah, we want this, the current height, or maybe we can have like next reduce height, so it will be 1, and yeah, for this we'll add 1, and we can have height here. And we'll have total. The last selected worker total will be our answer. Okay, next total is value. reduce height will be 1, basis value. Okay, maybe let's check this 1-5 example. So we will have 1 and 1 at first, and this will be 5. This will be 1. And okay, so at the first iteration we can reduce 1 for the height. We will select this since it has the least total, next total. So we will add 1 by base is 1. Let's see. So height is 2 now. Height is 1, base is 1, plus 1 total loss. No. I think we will still be current reduced height. Be easier to understand. And for this, this should added by 2. So base will be like for this it's 0. And we will select we will select this worker, and it will become reduced height will be 1, and the total for next will be height is now 0, so 0 plus 2 is 2. 2 multiplied by base will be 2, so it's 3. I think it will work for this. Okay. And for this, since next total 3 and 5, we will still select 3. So the next reduced height will be 2. Since 1 plus 1. And height is now 1 plus 2, 3. 3 multiplied by base is 1. So 3 plus 3 is 6. And 6 compared with 5, we will select 5. So let's put it back. We will select 5. And for now, its current reduced height will be 1. And for 1, the top height is 0, so 0 plus 2 is 2. 2 multiplied base is 5, it's 10. So 10 plus 5 is 15. Okay, and then it's for now reduce height. Okay, so 15 is 6. We will choose 6. Let's first reset Okay, we will choose 6, and for 6 we will have okay, height will be 3, yeah, and 3 okay, height is current 2. 2 plus 2 is 4. 4 multiplied by 1 is 4, so it will be 10. And for 10 and 15, okay, let's reset first. We will select 10, this one, so yeah, and 10 will be the current, it will be the output. Since, yeah, if we multiply this, it will be, like, height will be 4, right? And this will be, this is the prediction, so it will be 3 plus 2, 5, 5 plus base, multiplied base is 1, so 5 plus total 10 is 15. So this is the prediction, so we will return 10.